Worksheet 36-1, looking at the basics of magnetism. It says fill in each blank with the appropriate word. Number 1, attraction or repulsion of charges depends on their signs, positive or negative. Attraction or repulsion of magnets depends on their what? Someone want to take a stab at this? Grasso, what'd you come up with? Bingo, with their magnetic poles, and they are either what? North or south, exactly, okay? So instead of calling them positive or negative, traditionally, magnets were first used for navigation, right? In compasses. That's why we have north or south poles. Number 2, opposite poles attract. Like poles will what? Will repel. Easy stuff, right? Okay? It's just like electricity. Okay? Number 3, a magnetic field is produced by the what? Okay? The spin or motion of electric charges. In other words, you don't get magnetism from electrostatics, just electricity sitting there, but electric currents, okay? The motion of electric charge. Clusters of magnetically aligned atoms, we give them the fancy name what? Magnetic domains, right? And that's why materials like iron, what else did you guys discover from our mini lab yesterday? Okay, cobalt and nickel, okay, are magnetic. They're ferromagnetic. That's a fancy word for it. If you remember your chemistry, all it is there's an unpaired electron in one of the outer orbitals that you can then align all of them in the same direction. Otherwise, they're all paired off so the magnetic fields cancel out and the domains are randomly aligned. Okay? Blah, blah, blah. Number 5, a magnetic blank surrounds a current-carrying wire. A magnetic field. And in today's little mini lab, you're going to see what some of those field lines look like. Okay? Because magnetic fields, kind of like electric fields, okay, surround a source of magnetism, yeah? And magnetic fields can do useful things in real life, like float trains, transfer data to your really cool iPod video, etc., okay? Number 6, when a current-carrying wire is made to form a coil around a piece of turn, the result is called an electromagnet, okay? So all an electromagnet is you wrap a piece of wire into a coil, and then you put electricity through it. Now, usually we stick an iron core inside to boost the strength. That's all, okay? And tomorrow we're going to show you a honking huge electromagnet called a Thomson coil. We'll do a couple nifty demonstrations, okay? If you want a really dramatic example of an electromagnet, go to a junkyard, okay? Anybody know how they pick up the cars and drop them in to like the compact or whatever? Just a big old honking huge electromagnet, okay? You probably used one today and you didn't even realize it, okay? How many of you guys have power locks or power windows on your door, okay? Those are just electromagnets inside your car when you hit the button, chunk, chunk, okay? Big old electromagnet pulls the lock shut. Number 7, a charged particle moving in a magnetic field experiences a deflecting blank that is maximum when the charge moves blank to the field. Sure. William, what do you think? Yes, a force, and the key here is it's a perpendicular force, okay? So it turns out that electricity and magnetism, okay, are cousins to each other, and they exert forces on each other. So that's why when you move a magnet inside a coil, you make electricity, and electric current moving through a wire generates a magnetic field, but it's always in a perpendicular direction. That's how it works out in nature, okay? Number 8, a current-carrying wire in the magnetic field experiences a blank that is maximum when the fields are blank. Well, you know what? We just kind of gave that away, yeah? Okay, you feel a force, and it's also perpendicular when it's perpendicular to the magnet, okay? So in other words, electricity puts a force on a magnetic field, and a magnetic field will put a force on an electric current, okay? And that's how motors work in real life. Finally, okay, a simple instrument designed to detect electric current is called the galvanometer, which is a predecessor to the ammeter and the voltmeter, okay? This was just the last section of chapter 36 there, okay? And pretty much now we don't worry about using these old-fashioned instruments. All it is an old-fashioned voltmeter, an ammeter. It's just a coil of wire, okay, wrapped around some kind of core, and then when you run a current through a wire and then you put that up to that, the magnetic field then can deflect a generated magnetic field, an induced magnetic field inside that device, causing the needle to deflect. Tomorrow, we'll show you guys one, okay? An old-fashioned one. Now you guys are all spoiled. What do we use when we study electricity? We used a electronic digital multimeter, right? Which did all three, measured volts, amps, and ohms, right? Finally, number 10. The largest magnet in the world is, woo, the world. We are the world. The Earth is a big old magnetic magnet itself and makes a giant magnetic field. Okay? Back side of the worksheet is looking at how magnetic fields form in real life using iron filings and compasses. You know what? We're going to do this in lab. So don't worry about it if you had trouble with it. Okay? Just matching it up to the picture in your book. We're going to actually do this in lab. Okay? Speaking of